Swayam Prabha. Digital India. Educated India.
Right? Can I simplify things a little more? If I multiply by n, instead of multiplying by n, if I multiply by n minus 1, what will happen? What will I get? What representation will I get if I multiply instead of n by n plus 1, n minus 1? I will get gamma v plus gamma dot. What I am saying is, if you just multiply these characters of gamma x, y, z by n, the number of atoms that remain unchanged, unmoved by the symmetry operation, then you generate gamma 3n. That far is everybody okay? Sure? Janodhar? So say that. Why are you leaving this difficult task of reading your mind to me? Okay. You understood then? Do you understand? Did you understand then? Did you understand gamma x, y, z? You know how I got gamma x, y, z? Sure. So now, if I multiply gamma x, y, z by n, then what happens? N is the number of atoms that don't remain unchanged. For each of such atoms, the character is going to be corresponding to the character of gamma x, y, z for any symmetry operation. In gamma 3n, how did we get gamma 3n? We got some identical blocks, right? And so we just multiplied the number of atoms that don't change by the character of those blocks. Now I have already generated the characters of those blocks by taking gamma x, y, z. So after all, we are working with x and y and z, not fixed somewhere in space, but fixed to each and every atom. So whatever transformation we make to x1, the same thing will happen to x4 if x1 and x4 happen to be the unmoved atoms. Okay? So do you agree with me that gamma 3n can be generated by multiplying the characters of gamma xyz by the number of atoms that don't change place? Alright? So far so good. Are we all okay with this? Even if you are okay with this, it's easy, because then you know how to generate gamma 3n. Then just subtract gamma v, subtract gamma dot and gamma xyz from there. You got it. But what I am saying is, see, this gamma 3n is related to gamma xyz, isn't it? So chi r of gamma 3n is equal to chi r of gamma xyz multiplied by n. Right? Can I now move this out? What I am saying is, chi r of gamma 3n is equal to n multiplied by chi r of gamma xyz. Okay? So if I want, so this, what is this equal to? This is equal to chi r of gamma xyz plus chi r of gamma dot plus chi r of gamma vib Sure. So So now is it easy to simplify a little bit or not? So I will write this here, n chi xyz r is this. What do I want? I want to know what is this. So can I not write chi vib of r is equal to exactly n minus 1 chi xyz of r, then minus x नहीं है chi dot r. Right? Simpler formula, isn't it? So see, what are we doing now? We started with things like unitary matrix, unitary representation, class, this, that, right? Slowly we are moving towards a situation where we are generating a machine which can almost now work like a black box and give us answers even if we have forgotten everything that we have learned before medicine. And that is the idea. That is exactly what we want to do. But we now try to generate some general formulae which people can use easily to get whatever answer they want. So you like this formula or not? So you can work out what is gamma vib. Work out what is gamma vib then. You already worked out, right? So just check whether you get the same answer by this or not. So you should get the same thing. So basically what we are saying is that first work out these chi vibs, generate gamma vib from there, and then using your ai equal to 1 by h sum over r chi r data, chi r formula, decompose it into constituent irreducible representations. Understood what I am saying? Huh? Okay. So all these chi r's is going to give you gamma vib, then you decompose it into sum over I, ai, gamma I. All right, looks good. So that was one part of the story. Now what do we want to do? See, so far we have been able to perform symmetry classification of normal modes, but I don't know whether these modes are stretching modes or whether these are bending modes or what. That is no fun. So as chemists we want to know which normal mode is which. Just if you tell me that this is a symmetry, that I will not be happy with that. So let us see whether it is possible for us to work out, at least in a qualitative manner, which normal mode has contributions of what kind of molecular motion. Right? What are the different kinds of vibrational motions that you can think of for say BF3 or C carbonate? One is stretch. What is the meaning of stretch? Bond lengths will increase and bond lengths will decrease. So you can also think of bend. Now bend is also, let us first say the in plane bend. You can think of in plane bend. So bond angles will change, bond lengths will remain the same, right? And the third kind of motion would be the doming motion that we were demonstrating. That is out of plane. That is the only out of plane motion that can take place. And normal modes are going to be the linear sums of these different kinds of changes in these different kinds of parameters, right? Changes in bond length, changes in bond angle, and out of plane motion. Which day is it today? There is a class after this. All right, I will stop.